the place of women in STEM. This has been a recurring theme since the beginning of the lecture series. The first one, in fact, dealt with the hidden female figures in Marie Curie's lab, and the invited speaker, Nathalie Pijar-Micot, discussed the opportunities Marie Curie gave to 45 female PhD students and researchers over the years. The fifth conference was less optimistic and looked at the widening gender gap in computer science, a field where women were initially well represented, for computer programming used to be women's work, as demonstrated by our speaker, Valérie Schaffer. Today, with Marilee Benore, we will again look at the bright side of women in STEM, as she will explore factors that influence women's persistence in STEM. Before I give her the floor, let me introduce her properly. Marilee Benore is a professor of biochemistry and biology in the Natural Sciences Department at the University of Michigan Dearborn. Her BA in chemistry and AA in psychology were awarded from Thomas More College, Kentucky, in 1979. And she earned her PhD from the University of Delaware in 1986. At the University of Michigan Dearborn, she specializes in teaching biochemistry and incorporating research practices in the classroom. She has created courses and programs that intersect foundational areas in science, gender studies, and diversity. Her research focuses on 3 areas: vitamin transport, biochemistry education, and women in STEM, science, technology, engineering, and math. She's here at the UVSQ as a visiting professor to conduct research on women in STEM by gathering data and conducting oral histories in order to understand persistence factors. So potentially, ladies, you are all possible participants to our project, and I hope some of you will take part in it. The aim of the talk today will partly be to explain your project. I therefore thank her for having come to us, including the University of Versailles Saint-Quentin, in her research. I also thank you all for attending her talk. I thank the Dean of the Science Faculty for hosting us, and Fabienne Misgish for helping me organize this conference. And now, Marilee, the floor is yours.
So I plan to use surveys and oral histories to find factors that influence persistence. I don't know about France, but in the United States, persistence is a big research term. We're understanding the persistence of people, and there's books that say she persisted and they persisted. So persistence is a word that's quite important, especially as we also have the Me Too moment, globally. But first, let me tell you a little bit about the University of Michigan Dearborn. We have a memorandum of understanding with your university. Although mostly it was through engineers, I work with a lot of engineers, so they told me about the MOU, and our campus is doing more exchange. So the United States, you might know all of this already, but I'm telling you anyways, just so you have some placement. So the United States, Alaska and Hawaii are not shown. Michigan is right here, and it's surrounded by Great Lakes. It's actually 2 peninsulas, and Dearborn is right here. If you talk to anyone in Michigan about where they're from, they will show you the mitten. We call it the mitten, and Dearborn is right here. Okay? So the University of Michigan Dearborn was founded about 60 years ago. Henry Ford Automotive, is located in Dearborn, Michigan. And Ford created our campus as part of the University of Michigan Dearborn to help educate the engineers. There was a 2-year program, but he wanted them to receive bachelor's degrees. So our campus really was begun as an engineering university. The University of Michigan system, there's 3 campuses, one in Dearborn, Ann Arbor, and Flint, Michigan. And there are 14 state universities in Michigan and many, many private universities and colleges. University of Michigan itself is 200 to 300 years old. It's also considered one of the best public universities in the United States. So we are located, Henry Ford gave us his estate, and so that is where we are located. It's a lovely campus. We have about 200 acres of natural area, which we bring thousands of kids to every year for science education in the environment. So, and I'm a member of the College of Arts, Sciences, and Letters. Okay, so my role, I know there's a little bit in the introduction, but I'll tell you a little bit about it. The classes I teach are primarily biochemistry. We have a Department of Natural Sciences, which means we have biology, chemistry, physics, environmental science, geology, okay? And as a result, it's a large department where we usually collaborate, and it works very well to be able to talk to all of my colleagues. So I began teaching biochemistry, and then after time, I began teaching biology. My degree was really in chemistry, but they needed someone to work the biochemistry towards biology, so now I teach introductory classes in biology. Because my research is related to vitamins, I have begun teaching a nutrition class, and sometimes I teach gender in science and engineering and diversity in healthcare. We teach 3 classes a semester on our campus. All right, we have a fairly heavy teaching to research load. My research primarily is on vitamin transport, but also on biochemistry education, which was the lab manual that they showed you, developing best practices to teach undergraduates, and also, of course, women in STEM. In service, I've had a number of roles. I've been director or chair of programs. I was associate dean for a few years. We have a program called Women in Learning and Leadership, and I directed that. It brings women students and men from across campus to support women. The University of Michigan has a campus-wide, all 3 campuses, committee called Academic Women's Caucus, so I served as chair of that for many years, and I've worked on a number of programs. Most recently, we began a new program. We have an interdisciplinary scholar award, and that's my current role, as an interdisciplinary scholar. But I have to tell you, this is a culmination of my work with women. I've always been interested and supported girls going into science and engineering and women in science and engineering. But as a new faculty member, as an assistant professor, it was made very clear to me I could not do this, that I had to focus on the science, which was appropriate, and I was told that although they liked it, they would miss me when I was gone because I would not be here anymore if that was the focus of my work. I needed to focus on research. So that's what I did. I had some funding from the National Institute of Health and worked on vitamins. I will tell you a little bit about the research just because I love to talk about my research. We have a flock of mutant chickens discovered in 1954 that cannot make the protein that transports riboflavin to the egg. We can inject riboflavin into the egg so they survive. The chickens were kept at Penn State, University of Pennsylvania, and then at the University of Delaware. And after my advisor retired, he sent them to me in Michigan. So now we use these eggs in our research. We are doing genetic development or studies. We purify the protein because the protein is very stable, and we do hope to develop an assay to measure riboflavin. There are very few inexpensive mechanisms to measure riboflavin in at-risk populations. No one in the United States is riboflavin deficient, but it is a problem globally. So here is a picture of normal egg white, which is a slightly yellow color, and here is the egg white from our mutants. And so they die at the embryos die at day 13. It's very similar to some metabolic diseases, okay? So, I will make it clear again later that I only began more active work in gender and science and engineering in the last 15 years. When I became as I became a full professor and I took on other duties and began to collaborate in my research lab with 2 other women and one other new assistant professor who does bone development, I felt I could spend more time on the women in STEM work, which was so important to me. Okay. I think many of you already know this, but I'm going to go over some of the background first. Fewer girls choose STEM education. The number of women in STEM varies by discipline and country, and I'll show you a couple quick slides of that data. Many women leave STEM completely, or they switch and choose what some people define as BASE, which is business, humanities, health, social science, and education. For example, on our campus, we see if women leave engineering, they still love math, so they go into math education, if that makes sense. So more women than men leave STEM, so we know lots of people leave science and engineering, but more women than men do, and the reasons are personal, political, and systematic in the policies and politics. And so we need some global consensus in order to solve this problem because it's a global problem. So I'm going to review the data, the need, and my project. So the leaky pipeline, which I'm sure you have all heard, but not everyone has, is the pipeline. This is from a World Economic Forum, and I like this diagram. So it shows you the number of students, bachelor's, master's, PhDs, and researchers. And of course, this varies. We have more women in biology, fewer in computer science as you go through. In fact, a large number of the bachelor's graduates in many countries is biology majors. So women in STEM in France, last week there was an article, or 2 weeks ago, in The Conversation, which I was not familiar with before. Anyways, and so it was some researchers talking about the problem in France and summarizing this, so I thought I would use this article. And you can see that over the ascension through the program and to the grades, we don't use grades, but I think you do, you can see that fewer men start, but towards the advance, there are more men. Women hit the glass ceiling, or for other reasons, they just leave. And here's some statistics, 61% in life sciences, but in math and software, there were very few, and they had numbers for both universities as well as business research. So one of the things we need to examine is the policies and the politics, as well as the personal reasons. And policies for gender parity are more consistent in France than they are in the US, which is important. You have more consistent policies for maternity leave and health care and things like that. But there is a problem. Women receive fewer patents, and the employment conditions are less favorable for pay and stability. Okay, this is women in science and engineering in the EU. And this was just a good graph. And you can see France is here, EU average, and this includes science and engineering and not technology. Different countries keep defining the careers differently. But you can see that, in contrast, in Lithuania, there's a large number of women in science and engineering, and significantly fewer in all areas of science and engineering in Hungary. So clearly, there are differences in policies, education, and other systems that we could evaluate to find out, why is it working here? Okay, in the US, there's not gender parity. More young women enter college, fewer get degrees in STEM. From work done by the AAUW, which is the American Association of University Women, we know women have to receive higher degrees to receive the same pay. There's some concern that fewer men are going to college now, more women. But the fact is, if a woman has to earn a bachelor's degree to earn the same average salary as a man with a high school degree. So women are encouraged to go to college in order to get the pay that they would need to raise a family. Minority women are particularly underrepresented in STEM. In the United States, maybe 1 out of 20 women of African American descent are in STEM. And this is a problem because we estimate that underrepresented groups will be as much as 50% of the US very soon. So we need to achieve parity. As I mentioned, more women are in life sciences, biology, environmental sciences, And the reasons for that are probably because they see the applications more readily to human health and welfare, or at least that seems to be what the data tells us, but far fewer in engineering and tech. And in fact, we are decreasing in the number of computer science majors for women. It was closer to 25%, maybe even 10, 15 years ago, and now it's down to less than 20%. Women are more likely than men to leave tech. Employment conditions are less favorable. There's very little power behind the attempts to reach parity. We have some crises in the US anyhow of politics where people feel like they're being cheated, so equity doesn't seem fair to many people because they feel that they're not treated equitably. There's also a lack of networking and funding. We know that women in the US and probably worldwide find it more difficult to get collaborations and other situations. In the US, college is very expensive. If you were a student at the University of Michigan, Ann Arbor, and you lived on campus, it would probably cost you $40,000 a year, 45,000 euros. So the debt in our country is very high. One of the ways to get around that is that in high school, you can take tests that let you skip some classes. I don't know if you have that here. No. So what we find is that boys are more likely to take these tests. And when they take those tests, then they get to move through college faster, their debt is lower, and all of those things impact how long people stay in college. Retention in US colleges is very, well, it depends on the college, but it can be quite bad. In some universities, as many as 50% of the students drop out before they achieve their degree. So these are just different ways of looking at what some of the problems might be. In the US, like many countries, the number of women in STEM is increasing, but the pay gap remains. This is National Science Foundation statistics, which is one of the largest science funding agencies in the US. And you can see that the college-educated workforce of women is increasing, but there are still problems in pay differences and the wage gap. There's a large total difference in the different degrees, doctorate, master's, and bachelor's. And some of this can, when you still examine what their education is and what their actual job is, or other demographics, you still find that that exists. So it's not just because women are in different jobs. In the same job, they're still paid less. Okay. There have been some lawsuits about this. One of the issues in the US is family leave and child care. There are very few policies on how much time you can take off, and it depends. If you're in a small company, they don't really have to hold your job for you. In a larger company, they would. Only in the past few years have we begun paternity leave. Many companies do offer maternity leave. There's still a lot of pressure against men to take paternity leave. They think it will reflect poorly on them. But what we do know is that much of the child care, of course, still falls on the female. Child care is very expensive. And if you look at how many women leave after they had their first child, it's significantly greater than men. If we looked at the same chart for men, it would be many fewer men leaving their STEM career. So this then is a huge drop right off the bat. And of course, in science and engineering, if you leave the workforce for an extended period of time, it's difficult to come back to speed on the technology and the techniques. So just a few common factors. The politics vary, of course, and this is just a teeny snapshot. The gender balance, as far as I can tell, and with my conversations with people in France and reading, it's seen as a social justice and equality issue, and most people, I think, understand that, even if they don't seem to support it. And the European Commission and the European Union have implemented measures and policies to increase this. They're also aware that they need a skilled workforce and that there's a need for gender dimension in research, meaning the type of research where it was very clear that we were misdiagnosing women that had heart attacks because we were using the parameters by which we evaluated men. Lots of those kind of things. We have very similar problems with minority studies and everything else. In the US, Equality and economic needs coexist, but usually find people on separate sides of the divide. Politically, we're so at odds right now that there are people who want equality and talk about the economics, but many other people don't understand that economically it's critical that we have a STEM workforce that can do this. And so those arguments are being used to propel it, that we need everybody to increase in STEM. And that is important. Gender balances impacted by laws promoting and restricting balance. In Michigan, about 10 years ago, they passed a law that we are not legally allowed to offer programs that support women unless it's a federal grant. So if I were to try to have a program for women on my campus, if it was not federally funded, it would be found illegal. So I would have to include boys and girls in any programs. So that's what we do. If we say it's a program for women's leadership, but men and women can join, a few men and a lot of women join. So that's how we do it. So there's a STEM shortage, many efforts, education, university levels, but the laws and benefits completely vary from a university to industry to private practice. We are a union country, so depending if your job is a union job or not a union job, it can vary. Even on my own campus, tenure track faculty are not unionized, but the lecturers are unionized. So we have all this data that clearly shows there's a problem of the number of women in STEM, and they're kept by individual countries via government and professional organizations. We have a lot more data, of course, on academics because universities have to give data, so there's a lot of information, and college students are often the people that we can track and study. But the data is available, so international organizations have gathered and assembled the data for us and made these charts. And we can clearly see that the number of women in STEM careers varies by country, continent, and specialty, such as computer science versus biology. And we do know that equality is critical, but so is a skilled workforce. And those are the reasons that we can use to promote why we need to change the leaky pipeline and why we should change policies. Here's the UNESCO Institute's statistics that show more statistics, and it's the same thing. When they gather these statistics, you can see that there's a variation from the Netherlands to Latvia. The United States is not in here, probably because we pulled out of UNESCO this year. So causes for the leaky pipeline. We have studied a lot of the causes. I don't know if these are all the same causes that you have here, and it's one of the reasons I want to interview people and do histories. We know that family-work balance is a problem. We know that there's microaggression and demeaning behavior. Okay, microaggression means very subtle comments like, don't let the girls do that. Or I think men are better at math. So that's considered microaggression. And even though it's not obvious and overt, if somebody tells you often enough to be quiet or that someone else should be in charge, eventually you get sick of it and you leave. But the reasons are very vague and not well documented. But now they're finding that microaggression is a problem. We know that inconsistent policies for taking care of elderly parents or for childcare are very inconsistent. There's a lack of insurance. A huge number of people in the United States don't have insurance. So if you don't have insurance, it impacts your ability to get the kind of job you want, to get funding for transportation. A number of people in Detroit have no transportation. They don't have a car, and we don't have public transportation. It makes them very difficult for them to get to their place of employment. Childcare is very expensive. There's still quite a bit of sexual harassment. It's being brought to our attention more readily. I'm part of the American Society for Biochemistry and Molecular Biology, and just this year, they started a task force on sexual harassment in biochemistry and molecular biology, and I'm on that task force. So you still hear stories from people, but all too often these women who are harassed leave, okay? There's implicit bias, which means that people don't know that they have a bias. The studies that have highlighted this in the United States have sent identical resumes or CVs out to people, but just put different names on it, you know, Mary versus John. And both women and male scientists and engineers were more likely to hire the one with the male name. So it's very clear that this is bias that we all hold, but getting this training to change that is something that we do not do readily. On my campus, there's no required training for bias. We do, just this year, have sexual harassment training. If there's travel required, many conferences don't have childcare, so many women feel less able to attend. There's just a lack of awareness, and of course, traditional roles, okay? Just still parents not encouraging their daughters to go into STEM. Okay, so there's been a call for globally uniform data to create change because we need valuable, consistent data, and there's a fairly new project to look at both the drivers of women staying and being successful and the barriers. Why do women leave STEM? To persistence and success. And there's a number of groups working to address this issue, and I'm presenting this simply because they summarize it quite nicely. There's several working papers. One is on the situation, the other one is the call for the work they're going to be doing, and they're going to be doing global surveys to get the data and put it in a format that's consistent. For example, STEM seems obvious to most people, but in the United States, we've now changed it. Sometimes we include medicine, and now people want to call it STEAM. They want science, technology, art, technology, and medication, or math. So STEAM, we've got art in there, and we all know creativity is important, but it has changed the emphasis a little bit. So I'm going to highlight some of the work that they have as objectives, because these are all critical objectives that we see across the globe. We need to change perceptions, attitudes, and behaviors, which is the social norms and stereotypes. This is pretty much just cut and pasted with some paraphrasing. We need to engage girls and young women in STEM education. We need to attract, provide access to, and retention of women in STEM higher education. We need equality in career progression, gender dimension in research content, practice, and agendas. So if you were to apply for a National Institute of Health grant in the US, you have to demonstrate that you are including all populations, unless there's a reason not to do so. We need to promote gender equality in policymaking and in entrepreneurship and innovation. So all of these are clearly important. I've engaged in a number of these. I've held science camps for girls and scouts. In higher education, the National Science Foundation, which is the federal agency, has created programs called Advance, which is specifically to ensure that women are retained and promoted in administration and faculty positions at universities in the US. And it's been fairly successful because students are finding, like in our engineering department, until recently, we only had 2 or 3 women. We're trying to achieve 25% women in engineering faculty because that will make a difference in the comfort level of the women already there. Our Dean of Engineering is quite good. I really like him. So policy making and gender equality. So I've been participating in a lot of these for a long time, but I decided that I wanted to turn my attention in a slightly different direction because I think we're missing something. So this is what I want to focus on. Many women leave STEM careers, but many women persist. And why? What is the motivation and what is the success? We have not done enough to find the individual reasons, essentially the anthropology of what enables some women to stay. We've looked very hard at what is driving women out. We know some things that help women stay, certainly mentoring, coaching. Those are programs which have proven to be very effective. So I want to study personal stories to understand persistence, resilience, and self-efficacy. And then the personal goals. I think all of these will be the reasons some women stay in STEM. And I knew this from conversations with women and because I've been involved for a long time. My own reasons for sticking in STEM were not always reasons that made sense to anyone but me. I didn't want to tell my mom I changed my mind. And that doesn't seem like a great reason, but it was a motivator for me. That was a little hurdle, you know, the inertia that I didn't want to miss. So here's the research methods. Surveys and oral histories. So surveys, I've got a survey. I'm still actually changing it a little bit as I get feedback from people, and I hope to then send out the final version next week. What factors support, motivate, and encourage women in STEM? These are choices that we have not gotten as options in traditional surveys. So certainly education, career, but motivation, obstacles, self-evaluation criteria. For example, I asked in the survey about family support, but one respondent said you need to specifically ask mothers and fathers versus siblings, not just family, which I thought was interesting, but it has proven true. High school, for many young women going into engineering, their high school counselor was very important in encouraging them to go into education and engineering. But when they get to college, without that one-on-one mentoring, we tend to lose them. And that was cited as important. So this is a way to get some data. But the oral histories are a new venture for me. Oral histories are critical to understanding human behavior. Some of your faculty already do that. In your Siberian studies, for example, you have Alexandra is doing oral histories of the women. So you can use them to gather data. In the US, we have a lot of oral history projects that are large projects of veterans from World War II or Holocaust victims. Even though academically they've been used more readily in the past 40 years, we have been doing these for a long time. 100 years ago, we were sending people out to try and record or write down the music that was historic to the United States. So these are all oral histories, only now we can record them by video, as well as written transcript, or just audio. So this is what I want to do. So working with people, we will be doing interviews of STEM women, and I'm going to record them by video. And then, with some help from engineering, we can do analysis of the text and find factors that might be common. We can watch them, but in addition then, we will put these in a database. We have a database at the University of Michigan called Deep Blue. So after we do the video, after it's edited, then we can put, and then after the person approves that it goes into this place, they will serve there, and I think they will be important for mentoring of young women who might want to find something like this. We already know that, and there's many different efforts. This is just one of them. So we're going to do the videos in several different formats. This was a young friend, an engineer, who had studied in Tunisia and came to the United States, and I didn't put the video in here because she had not approved of the final one, but she talked about her reasons for entering engineering and what was important to her. And I'm not sure that her reasons would have been caught by a standard survey. Some people do not want their videos. Working with some librarians at the University of Ann Arbor campus, one suggested that instead of making an actual video, maybe we could put it in a cartoon format, almost like a little comic book. That also might resonate with a different audience. And then we can also use animojis. I'm laughing because I made some of these and showed them to students, and the first thing they did was burst into laughter. But then they said, no, it's a good idea. But that was after they stopped laughing. So there's several different ways that we can present these. It took a while to get institutional review board approval. On my campus, if you did an oral history, it would be exempt. But because I'm here in France, it was not. So it took a 45-page document to get approval to do this here. But still, not everyone will want this as an actual video, and they were very concerned about if it would expose someone. But my feeling is that if people do these, they will want people to see these videos. They want to serve as role models. It will be a benefit. So who's working on this with me? This is really just beginning. I've tried to get grant funding, and people said, well, you're not a social scientist, you're a scientist. I think it's really important that scientists do this and work with the social scientists. So one of my colleagues is from Jordan. She's considered a feminist Muslim scholar, and she made many videos, but was told, don't do that. So she published a different book on 5 scarves, kind of like wearing 5 hats, her many roles. And now she's at a leadership institute, and she would like to coordinate and write a book. Next week, I'm going to Romania because one of my colleagues is from Romania. She's going back for a conference, and she's set up some videos for me to do there, which is very exciting. And then I also have colleagues across the US. So it's really just coming together. I now realize that the best way to do this would almost to be have somebody on the ground in every country we want to evaluate, because you know the policies, and then you can ask the questions that are relevant in an oral history. So that's, I think, what we'd like to move towards. So we want to define the best practices. I don't know if that's a term in the US we use a lot. It means, if you say I'm using best practices, it means this is what works the best, and I'm doing it, so it implies that you're on the cutting edge of the way to do research. So the videos will increase the visibility and the scholarship of women, and hopefully increase some collaboration and productivity by people beginning to network. And this is important not just to women in STEM, but any underrepresented group. People often ask me, why are you just focusing on women? And it's because that's what I can focus on. I can't focus on everything. So we have other scholars working on Hispanic Americans and African Americans. So all of this, I think, will be helpful in terms of understanding persistence, resilience, and self-efficacy. Self-efficacy was a new term to me. It means your understanding of your ability to get something done. All of these have scales that can be evaluated by psychologists. So hopefully we will write a book, but we want to also coordinate exchanges. Even if we just make research papers or impact policy, that will be important. But one of the things we would like to do, and this is kind of come along, is coordinate exchanges. Women are less likely to be cited and to have the opportunity to collaborate. So I think hopefully by making these connections, we will find new ways for women to collaborate and new entrepreneurship activities as well. So thank you. One more slide. Past this. Why France? Why France? People are like, why did you come to France? Well, first, because in 2011, with one of our engineering faculty, I came to a conference here in Paris. And that's when I first really saw the variation that was in the EU, certainly, and got to meet all these women from these other EU nations. It was really important to me. And from that point, I realized I want to find out what helps women, since we are working pretty steadily on what's not helping. So that was important. Then, because I really liked France, one of our faculty members, actually from another campus, she left our campus, is a forensic anthropologist, and she was working in the northern part of France at St. Valery-sur-Somme on a bone project of ancient bones. So I talked my way into the study and helped with like the DNA parts. And we were there for 2 weeks, and each student had this amazing research project, and we were working with physicians from Amiens. And finally, a large number of people from France, about 300 years ago, left and went to Canada. There are several 100,000 descendants of those French Canadians, and I'm one of them. You had asked me about my last name, and it's not on here, but way over there you can find Benores and Bernards, and then you have Bergerons and some other things in here that are French and German descent. So all of this just suggested to me that I should come to France.
Why you explain that the boys take tests that help them go through college faster? Why don't the girls do it? Because in France, girls have higher success scores at high school, including in science.
Girls have higher scores in high school in the United States. The tests that we do, and we have a lot of tests, tend to be short. And so sometimes on other tests, they don't do as well, even though their grades are still good. But I think a lot of it comes down to encouragement from parents. And parents that are thinking about their kids going into science or engineering, no, you have to pay to take those exams. You have to pay to take them, and it's not a large fee, but maybe for $100 for the fee, let's see, one college course on my campus is about $2,000. So paying a very small sum gets you a big advantage. But you have to know about those tests, and you have to think that your son or daughter will be interested in engineering or math. And someone has to encourage them to take the advanced placement class so that they can then take the exam. So I think that's part of the reason. That's changing a little bit, especially as the cost of college in the US has gotten kind of out of control.
But in your university, have you done anything specific to attract girls into STEM?
Yes, yeah, most of these are student-led events. We have a lot of student organizations, so we will have, like the engineering students will have a robotics day, and they will invite girls in high school or grade school to come to the campus. Sometimes these are specific to our campus. I take my eggs and I go out to a lot of grade schools and high schools. Not a lot, but some, to try and encourage, again, both girls and boys to go into science. They get to play with an egg, they get to crack it open. Riboflavin is fluorescent under a black light, so they get to put on a big thing and check to see which one's a mutant. So they learn quite a bit. So we do outreach to schools as well as bringing them to campus. We did have something called Bring Your Daughter to Work Day. That was a very big effort in the United States, but it's dwindled. People said, well, it's not fair to take your daughter to work. You should be taking the boys to work too. So we actually canceled that on our campus this year. So we are making efforts, but it's inconsistent, and it depends on the student groups. Engineering is very active, and they have staff that is specifically working on outreach.
So does it mean that positive discrimination is over in America? Because we're just thinking about starting it here.
Oh, I think we need to do everything we can. I think we're hampered in Michigan because we have that law. Every state has different laws. In our state, we can't have programs just to encourage girls to come into science, but we can make them broad to encourage students to come into science and engineering.
Specific to your state.
This one, that is particularly specific to my state. It doesn't surprise me. I expect some other states to have similar, depending on their politics. This was a result, there was a huge lawsuit in our state. A student who got into law school that another student said it was not fair based on minority status, and it was a many-year lawsuit, and then the law was changed.